Hello students, I am ready with my next video number 10, again on mathematics for class 12th, that is PUC second year in Karnataka state. Again topic is differentiation, continuity and differentiability. Now we will see differentiation. Differentiation is another very important topic in PUC second year. Not only important for PUC second year, but when you go to higher degree, higher education like degree BSc or BE, this is very important. I have I have heard that many students left engineering only because of mathematics. They could not pass their mathematics because in their colleges mathematics was not taught, or it was not taught properly. Only they were teaching, they were making students ready for medical, and finally when they could not get admission in medical, they went for engineering. And in engineering, lot of maths is there. Mathematics M1, M2, M3, M4, mathematics 1, 2, 3, 4 papers are there, full of all these things. Calculus, differentiation, integration, and all that. And they could not pass that paper, and they left engineering and they went for some other degree or some other course. So this is important. Now let's see continuity and differentiation. This is differentiation now. Like, what is differentiation? Some students may think that what is differentiation? In PUC first year it is in detail, but here I just want to tell you that differentiation is, you can say, rate of change. Rate of change of one quantity with respect to the other is called differentiation. For example, sound and distance, rate of change of sound with respect to distance, or rate of change of area with respect to time, rate of change of volume with respect to time, rate of change. It also helps us in finding slope, which is another important thing. We can also find slope using differentiation. Now, this will not be asked in exam, what is a differentiation. They will give you the problems, you have to differentiate. You have to make use of differentiation and solve problems. That is important from examination point of view. Now, differentiation of constant, these are formulas of differentiation, important formulas for PUC second year students, 12th standard. Differentiation of a constant is always equal to 0. Differentiation of x raised to n, x to the power of some constant number, x raised to n is always n x raised to n minus 1. This n will multiply here and the power will decrease by 1. The differentiation of trigonometric ratios, differentiation of sin x with respect to x is cos x, differentiation of cos x is minus sin x, differentiation of tan x is sec square x, differentiation of cot x is minus cosec square x, differentiation of sec x is sec x into tan x, differentiation of cosec x is minus cosec x into cot x, differentiation of log x is 1 by x, differentiation of e to the power of x is e to the power of x, differentiation of root x is 1 by 2 root x, differentiation of a to the power of x is a to the power of x log a, differentiation of sine inverse x is 1 by root 1 minus x square. These are the differentiations of inverse trigonometric functions. Differentiation of cos inverse x is minus 1 by root 1 minus x square. Differentiation of tan inverse x is 1 by 1 plus x square. Differentiation of cot inverse x is minus 1 by 1 plus x square. Differentiation of sec inverse x is 1 by x root x square minus 1. Differentiation of cosec inverse x is minus 1 by x root x square minus 1. These are important formulas that we will be using while solving problems. Now, the important thing is you can note down these formulas, or you will find these formulas in different books. If you have a book of formulas, or if you're in your course book, or you can pause the video and note these formulas down in your notebook, right, and learn them by heart. If you don't learn them by heart, if you practice the problems, while practicing problems, you will remember these formulas. You will learn, of course. Now, differentiation, we have to write the question, given function. Question will be given an example, right? For example, if they give you y is equal to sine x, this is very easy. I'm just giving an example. This easy will not come. So easy will not come. Then we have to, if they tell us differentiate the given function, differentiate with respect to x, differentiate with respect to x, y is equal to sine x, then we have to differentiate y, differentiating y with respect to x, dx stands for with respect to x, differentiation of y, given function y with respect to x will be, we know that differentiation of sine x is cos x, that is very easy. Now, I give you another example. There are some questions like, for example, y is equal to sine u. We have to differentiate this with respect to x. The differentiation of this will be dy by dx, differentiating y with respect to x again. Differentiation of sine u, we know differentiation of sine is cos. So that will be cos u. Same function will come, same angle will come into, we have to differentiate u also. The question comes, why did we not differentiate x here? Because differentiation of x, if we differentiate, it will be 1. Cos x into 1 will be cos x again. Differentiation of x with respect to x is 1. Differentiation of x with respect to x will be 1. Therefore, when angle is x here, no need to differentiate. Even if you differentiate, it will be 1, and then product of 1 into that function will give you the same. So no need to do that. But here, in place of x, we have u. We have another function of x. So in this case, we have to differentiate. Differentiation of sine u is cos u. What is the differentiation of u with respect to x? That is du by dx. This is important. This is called chain rule. This type of questions are given in exam. For example, one more example. I give you y is equal to log of sine x. Like usually, we have already seen the formula of log x. Differentiation of log x is 1 by x. But here it is x. But here with log, it is not x. It is sine x. It's not just x. It is another function of x, sine x. Right? So that will be dy by dx will be equal to log, this is like x, right? Log, it is like x. But in place of x, we have sine x. Differentiation of log x is 1 by x. So this will be 1 by sine x. Log x, 1 by x into, we have to differentiate this also. We cannot just leave like this. This, because if it was just log x, then dy by dx will be equal to 1 by x into, no need to differentiate x again because it will be 1. And 1 by x into 1 will be 1 by x only. Therefore, no need to do. You just write 1 by x. But here, we don't have just x, we have sine x here. So we have to differentiate sine x also. Y is equal to log of sine x. Differentiation will be 1 by sine x, just like log x, 1 by x, log sine x, 1 by sine x, into, what is the differentiation of in product, in multiplication, you have to differentiate this, that is cos x. What about this x again? This also we have to differentiate, but no need. Why? Because differentiation of x will be 1, even if we differentiate it will be 1, and that will not make any difference. So that will become cos x divided by sine x, which is equal to tan x. This is how we differentiate chain rule. We use chain rule. Now, we have some problems came in previous exams. But before that, I want to teach you two important formulas. Two more important formulas are there. They are called product rule and quotient rule. Product rule and quotient rule. Like for example, what if question is like this? Y is equal to u into v, where u and v are again two different functions of x. Like this may be sine x, this may be log x, or this may be x log x, x sine x. Sin x into cos x. It may be like this, right? So this is called product rule. Product rule. What is product rule? Remember, in product rule, when two functions are in product, then we have to differentiate like this, differentiating first function u as it is, then differentiation of v. Differentiate the second function plus second function v as it is, write it as it is, then differentiation of u with respect to x. This is called product rule, UV rule of differentiation. Like for example, if it is like this, suppose we have x log x. This is x, u, and we have another function in product v, u, v, right? So differentiation will be, differentiation of this will be, right, like this, dy by dx is equal to first function u as it is into derivative of second function. Derivative of second, what is second function? Log x. What is the differentiation of log x? Log x is 1 by x. So differentiation of log x is 1 by x plus second function v as it is, log x as it is, into du by dx, differentiation of first function. Differentiation of first function x, here first function is x. This is u, this is v, right? U, v, u into v. U as it is, differentiation of v plus v as it is, v as it is, differentiation of u. What is it? Differentiation of x with respect to x. I just showed you differentiation of x with respect to x will be 1, right? So that is 1. Now we can simplify it. dy by dx will be this x, x will get cancelled, 1 plus log x into 1 is log x. This is called product rule. When two functions are in product, don't get confused. Like for example, log of cos x. This is not product of two functions. This is not product of two functions. Here two functions are. This is product. For example, if it is like this, log x into cos x. This is product of two functions. This one, it is one function only, but log, in place of x having x, we have a function. This is chain rule. We use chain rule here to solve, right? I have already showed you. So dy by dx will be log, it is like x, right? Log x differentiation is 1 by x into, then we have to differentiate this also. So cos x is minus sin x, that will be minus tan x, will be the differentiation. This is how, this is the difference between product rule and this is not product rule. For example, if it is sin root x, it's not a product rule. But if it is like this, sin x into root x, this is product rule. Or root x into sin x is product rule. This is the difference between product rule and chain rule. You have to remember, right? Okay. Then we have quotient rule also. You can pause the video and note down the rules, formulas. We have quotient rule. One more is there called quotient rule. Quotient rule or u by v rule. What if there are two functions which are in quotient with each other? Differentiation of u by v. For example, x by sin x. If it is like this, right? U by v. So we have to do this. V as it is, denominator as it is, differentiation of u, differentiation of numerator, minus numerator as it is, denominator as it is, differentiation of numerator, divided by denominator square. Denominator as it is, differentiation of numerator minus numerator as it is, differentiation of denominator whole divided by denominator square. This is called UV rule. This is called U by V rule. This is called quotient rule in differentiation, right? For example, I showed you x by sin x. If you want to find the differentiation, this is a given function, right? So differentiation will be denominator as it is into differentiation of numerator, differentiation of x is 1 minus numerator as it is, Differentiation of denominator, sin x differentiation is cos x divided by denominator square. So that will be sin x minus x cos x divided by sin x. This will be the answer. If we cannot simplify more, if we can, we will do, otherwise we leave it. This is called U by V rule. Learn these formulas, learn these rules, watch my video again and again, and write down the problem and solve. You will be good at this topic, right? This is very important topic. Now, let's solve some problems that came in previous exams. Let's solve some problems came in previous exams. Differentiate f of x is equal to sine of x square plus 5 with respect to x. This is the question. Differentiate f of x is equal to sine of x square plus 5 with respect to x. This is the question. This will come for 1 mark or sometimes 2 marks, right? So write down the given function. Given function is f of x is equal to sine of x square plus 5. This is the given function, right? Previously I was writing y is equal to, so I wrote dy by dx, differentiation of y is dy by, so differentiation of f of x will be f dash of x. If it is y, you can write dy by dx. If it is f of x, you can write f dash of x. This dash, it represents differentiation of f of x. First order derivative, 1 dash, first order derivative, f dash of x is equal to, now we have to differentiate this, right? This is in the form of sine x, but in place of x, we have x square plus 5. What is the differentiation of sine x? What is the differentiation of sine x? We have already here, sine x differentiation is cos x. But here we do not have just sine x here, it's x square plus 5. So in place of x, like for example I told you, sine x differentiation will be cos x into, we must differentiate x, but we do not, because it will be 1. Right, but here it will not be 1, so we have to differentiate, right? Sine x square plus 5, the differentiation will be cos x square plus 5. This is the differentiation of sine. The differentiation of sine is over cos. Because sine has x square plus 5 angle, so cos will also have x square plus 5. So differentiation of sine x square plus 5 is cos x square plus 5 into, now in product we have to differentiate this. This is in the form of x raised to n. X raised to n. N here is 2, right? So it will be 2 x raised to 2 minus 1. N x raised to n minus 1 plus, what is the differentiation of 5? 5 is a constant, it will be 0. 5 is a constant, derivative of constant with respect to x is 0. So differentiation of constant will be 5. So that will be cos x square plus 5 into, this will become 2x, right? 2 minus 1 is 1, 2x plus 0 you can leave. So that means 2x into cos x square plus 5. This is the required answer. This question previously came in exam. This is how we solve it. Another important thing I tell you, like for example, if we have y is equal to 2 sin x, y is equal to sin x by 2, y is equal to 2 plus sin x, y is equal to sin x minus 2. Observe. Here constant 2 is multiplied to sine, right? So if you differentiate this, keep 2 as it is. So its differentiation will be dy by dx is equal to 2 as it is, differentiation of sin x is cos x. When constant is multiplied to the function, keep it as it is. What about when it is in quotient with the function? Keep it as it is. So differentiation will be again 2 as it is. This divided by 2, 1 by 2, 1 is here, 1 by 2. Differentiation of sin x is cos x. This, for this here is the answer. What about this one? after this you have to differentiate 2 also. When the constant is in addition, when constant is in sum, in addition with the function, then differentiate. What is the differentiation of 2? It will be 0 because 2 is constant. Differentiation of constant is 0. Plus, what about the differentiation of sin x cos x? So the answer is cos x. What about this one? This one also, dy by dx will be equal to sin x differentiation is cos x minus, what about differentiation of constant? 0. So answer will be cos x. So now here, these two, in these two, constant is multiplied here and constant is in quotient with the function, right? So when constant is in product and quotient, keep it as it is. Just differentiate the function. When constant is in addition or subtraction, in addition or in subtraction with the function, then you have to differentiate the constant also. Do not leave it, do not keep it as it is, unlike here. This is how we solve, right? Some more problems are there. We will solve some more problems. Tomorrow again I will upload another video. This is differentiation. Learn the formulas well and try to solve these problems. More problems will be discussed tomorrow. Thank you for watching, and do not forget to share my video, and please tell your friends and your relatives to subscribe my channel. Thank you very much.